Math 082 Practice Final Exam Review, Problems 47, 48, 49, and 52. I have grouped these problems together because we will solve these four different systems of equations in these four problems using the method of elimination. I'm going to use the method of elimination because in this equation, neither of the variables is isolated, and in this equation, neither of the variables is isolated. So that suggests that we should try elimination. For elimination, you want to find or create exact opposite coefficients for one of the variables. And it doesn't matter which one you pick. I am going to eliminate the y variable because I can easily make those exact opposites. I'd like a 2 right here because then this 2y and this negative 2y will add up to 0. Now to legitimately make a 2 right here, I actually have to multiply this entire equation by 2. Distributing, I have negative 4x plus 2y equals negative 2. The second equation will be unchanged. Now adding these two equations together, I bring down that equal sign. Positive 2y and negative 2y add up to 0. Negative 4x and negative 1x make negative 5x. Negative 2 plus negative 8 equals negative 10. Dividing both sides here by negative 5, we get x equals positive 2. Now going back to either one of the original equations, it doesn't matter which, I am going to plug x equals 2 in right here. That gives me negative of the 2 that I'm plugging in minus 2y equals negative 8. To solve for y here, I will first add 2 to both sides. I get negative 2y equals negative 6. Then dividing by negative 2, which is the number multiplied with the y, I get y equals 3. So the solution of the system, x is 2 and y is 3. 2, 3 is the solution. Let's check that. Problem 48. Again, we are going to use the elimination method because this equation does not have an isolated variable, and this equation does not have an isolated variable. We begin by asking ourselves, which of the two variables should we eliminate? In the long run, it doesn't matter, but if you look closely here, this coefficient of y is negative 1. This coefficient of y is positive 1. Exact opposite coefficients. So with no adjustment to either equation, we can add the two equations together and eliminate y. Negative y plus y is 0y. Bring down that equal sign. Negative 5x plus 0.5x, that's like negative $5. Gaining back 50 cents is negative $4.50 or negative 4.5x. 7 plus 2 is 9. Divide both sides by negative 4.5. We get x equals negative 2. We put this back in either one of the original equations. Let's go right back here. So we have negative 5 times the negative 2 that we're plugging in minus y equals 7. 10 minus y equals 7. Well, I know 10 minus 3 equals 7, so y must be 3. And the solution of the system, x is negative 2, y is 3. And if you have the opportunity, you should check these by plugging negative 2 in for x and 3 in for y into the other equation to see if you get a true statement, which you will. Let's look at the answer key. Problem 49. We will use elimination because this equation does not have an isolated variable, and also it is the case that this equation does not have an isolated variable. We see here that the coefficients of y are exact opposites. So we can add these two equations together right away and temporarily eliminate y. Bring down that equal sign. Negative 5x plus 1x is negative 4x. Negative 3 plus negative 9 is negative 12. Divide both sides by negative 4. We get x equals 3. Put this into either one of the original equations. I will put it right here. That will give us 3 plus 3y equals negative 9. Solving for y, I will subtract 3. We have 3y equals negative 12. divide by 3, y equals negative 4. So the solution of the system, x is 3, y is negative 4. Let's check that. And we're jumping over to 52 because we will use the elimination. Again, because neither equation has an isolated variable. We have to decide which variable we want to eliminate. In this situation, we don't see exact opposite coefficients for either of the two variables, so we arbitrarily pick. Let's say I want to eliminate x. What I do is I want to find a common multiple for 7 and 3. 7 and 3 both divide into 21 without remainder, so I want to make one of these coefficients positive 21 and the other coefficient negative 21. I will multiply by 7 to make a coefficient of positive 21x. But I have to distribute that 7 through the entire equation on both sides. Since I decided already to eliminate x, I want to make negative 21x. That will require distributing negative 3 through the entire equation. Negative 21x minus 33y. Negative 3 times negative 2 is positive 6. Now when I add these two equations together, bring down that equal sign first, 21x plus negative 21x is 0x, temporarily eliminating x. Negative 35y plus a negative 33y is negative 68y. 28 plus 6 is 34. Dividing both sides by negative 68, I get y equals positive divided by negative is negative. 34 divided by 68 is a half. I want to take this value of y and replace it into either one of the two original equations. I will put it right here. So we have 3x minus 5 times negative 1/2 equals 4. Negative times negative is positive, and 5 times a half is like 5 over 1 times a half. That gives you 5 halves. We will subtract 5 halves from both sides in order to solve for x. Now 4 minus 5 halves, what is that? Well, 4 is the same as 8 halves, right? 8 divided by 2, that's 4. So I have 8 halves minus 5 halves, and that is 3 halves. So I have 3x equals 3 halves. Now to solve this, I'm going to multiply by 1/3 on both sides. On the left I have 1/3 times 3 over 1. Those divide out to 1. I get x equals, these divide to 1, and I get 1/2. So the solution of the system, x is 1/2, y is negative 1/2. Let's check that.